In this video, I'll show you how to solve the ALEKS problem called Deducing the Empirical Formula of a Binary Ionic Compound from its name. This problem is going to give you the names of two ionic compounds, and it just wants you to write the empirical formula. In order to write the empirical formula, you need to know the symbols and the charges of the ions that are in this ionic compound. I want to begin by reminding you, conventionally, the first ion in the molecule's name is the cation. Also, the first ion in the formula is the cation as well. The second one is the anion. So the first thing that we're looking at here, the nickel, and then in parentheses we have, this is a Roman numeral 2, this is not an 11, in parentheses. If you have the name of an atom followed by a number in parentheses, and it's always going to be a Roman numeral, it's not going to be like a normal number 2. If you have this notation, this in parentheses is actually telling you the charge of the ion. So we know from that Roman numeral 2 that this is the nickel 2+ ion. You're going to see this notation used for metals that are in this, oops, I missed an area, in this area of the periodic table, the transition metal area. Because these metals have charges that are difficult for us to predict, the charges are always provided to us in the ionic compound's name. So that's super handy. So for example, if it had said nickel with a 4 in parentheses, we would know that that was the 4+ ion. Our anion is the chloride ion, and that is located right here on the periodic table, and it's not giving us any hints about what the charge is on that ion, but that's okay because it's pretty easy for us to predict the charges of ions based on the atom's location on the periodic table. All of the elements in the first column, they form +1 ions. The next ones form +2 ions. Remember, you don't have to worry about these guys. Their charges are going to be given to you in the name. These elements form +3 ions, skip that column. These form -3s, -2s, -1s, and then skip these guys as well. So you can just find the atom on the periodic table. You can take a look at what row it's in, and that's going to tell you what its charge would be if it were an ion. For chloride, it is in the -1 column, and so that means we have the Cl- ion. Now, to come up with the empirical formula, we need to figure out how many of each type of ion is necessary to create a compound that is overall charge neutral. Since we have a 2+ ion with the cation and we have a 1- ion for the anion, we know that we're going to need 2 of these guys to balance out the +2 charge. If that kind of math is a little bit tricky for you, one of the things that we can do, kind of a shortcut, the charge on each ion is the quantity of the other ion that we need. So the charge on the chlorine is a 1-, and that 1 tells us that we only need 1 of the nickel ion. When there's a subscript 1, we just don't write it at all, we leave it out. The charge on the nickel is telling us how many of the chlorides we need, NiCl2. For our next one, we have magnesium fluoride. There aren't any hints about what the charges are. There's no Roman numerals in this name. That's fine. We just need to find magnesium. There it is. It is in the 2+ column. Fluoride is right above chlorine, so it's right here. It is in the 1- column. Looks like we have the same kind of a thing. The charge on the fluorine is the number of magnesiums we need, that is just 1, and the charge on the magnesium is the number of fluorides that we need.